Welcome everyone to Makaut Electrical Engineering channel. So today we're gonna discuss three important theorems which comes for the semester exams. So the first theorem is Norton's theorem. Okay, first of all, whenever you write a derivation, make sure first of all you give some introduction, then you give the circuit diagram, and then you explain the further things. Okay. So first of all, when you explain Norton's theorem, explain a little bit about Norton's theorem. Okay. So any two terminal device, any two terminal active network containing voltage source and resistance when viewed from output terminal is equivalent to constant source, constant current source and internal resistance. The constant current source is called Norton's equivalent current source. Okay, what does this statement means? Okay, so the Norton's theorem says that any two terminal active network means there is a two terminal network. Okay, so let me draw two terminal network for you. So here one terminal, the other terminal. Okay, so this is a two terminal network containing a voltage source. So we are having a voltage source here. Okay, so this voltage source I am denoting it as E. Okay, E, or we can take it as V, whatever we want. I am taking here it as E. Okay, now there is a resistance. Okay, so and resistance, so here is some resistance here. Okay, so in this circuit there is some resistance. Okay, when viewed from the output terminal, so there is a resistance source and one more resistance source is there, R2. Okay, so one voltage source and two resistances, R1 and R2 respectively. Okay, so when this is output viewed from output terminal, it is equivalent to constant current source and its internal resistance. So whenever we view it from here, okay, whenever we view it from here, it will appear as a constant current source. Means here is some equivalent resistance, isn't it, RL, and this will be equivalent to, whenever you view it from here, it will be, this circuit will be equivalent to constant current source and internal resistance. Okay, so internal resistance is here is RL and the constant current source is IL. So the current flowing through the equivalent resistance RL is nothing but your constant current source. So it's saying that finally, means from Norton's theorem, what we will get? We'll get the value of IL. Okay, so what are the steps? There are mainly three steps involved in Norton theorem. So step 1, this portion carries 1 mark. Okay, this portion carries 1 mark, and the three steps you're gonna write will carry your 3 marks. Okay, 1 mark, the diagram 1 mark, and the 3 steps 3 mark, total 5 mark. Okay, step 1 is remove RL. Okay, so what we're gonna do, we are going to remove RL. This RL, we will be removing it from the circuit. Means the moment we remove this RL, the circuit will act as a open circuit. Okay, so here again we will draw the EMF, same circuit, the resistances R1, okay, and R2, and they've said that to remove this RL means this RL is removed, so this circuit will act as an open circuit, isn't it? So this is your E, R1, R2, your R, this is removed, okay, from these terminals. There are two terminals, right, A and B respectively. So from these two terminals this RL is removed, the circuit behaves as an open circuit. Now step 2. Actually in step 2 we have to find the internal resistance, okay, that is RL we have to find, okay. So for step 2 find internal resistance, okay. So again draw a circuit, okay, this is my circuit. I take this as R1, okay, I take this as R2, and finally the circuit is open and I have to find this Ri, internal resistance Ri. Let me consider this internal resistance as Ri, okay. So this is R1, R2. Whenever you find the internal resistance, don't forget that you have to remove the voltage source, okay. Remove this voltage source I have removed here. Can you see this? R1, R2, and this finally I have to find this Ri, okay. So Ri value is basically Ri equal to nothing but, can you see these two things are in series, okay. For series it is R1 R2 by R1 plus R2, okay. Okay, for step 3 we have to form a Norton's equivalent circuit, okay. Step 3, to form Norton's equivalent circuit. So for forming a equivalent circuit you should have a voltage source, okay, and equivalent resistance, okay. So I'm taking this equivalent circuit as like this, okay, one voltage source or a current source and a resistance, equivalent Norton's resistance, and finally your RL. So this is my RL, this is my current source IN, okay, constant current source IN. This is my equivalent Norton's resistance RN, and this is equivalent resistance RL, okay. So point A, point B, the current I have to find IL. So this IL I have to find in Norton's equivalent circuit, okay. So this IL will be equal to this IL will be equal to IN, okay. This IL will be equal to IN, that is Norton's equivalent current, or we can say equivalent constant current, into RN, this RN equivalent Norton's resistance RN by RN plus RL, RN by RN plus RL, RN by RN plus RL. This is my Norton's equivalent circuit. I am getting this equivalent current from here, okay. That's all. These 3 steps and you'll get 5 marks.